Open-weight model releases and performance. The Mohammed bin Zayed University of Artificial Intelligence, MBZUAI, has dropped K2V2, a fully open 70 billion parameter model that joins the ranks of truly transparent releases like OLMO3. Unlike the carefully hedged open releases from major labs, K2V2 comes with everything: weights, training data, code, and documentation. The model's benchmark performance tells an interesting story. An IFEVAL score of 89.6 suggests solid instruction-following capabilities, while its math score impressed commenters enough to warrant excitement. The catch? Long context performance lags significantly, with long bench V2 clocking in at just 42.6. This makes K2V2 an excellent foundation for further training rather than a drop-in replacement for production workloads requiring extensive context windows. Community reception has been cautiously optimistic. Early adopters are already grabbing Q4KM quantizations to test on consumer hardware, though concerns about memory requirements persist. The model represents an important data point in the ongoing debate about dense versus mixture of experts architectures. While some commenters questioned whether anyone still cares about large, dense models in the MoE era, the response suggests plenty of researchers and hobbyists remain interested in well-documented, fully reproducible dense models for experimentation and fine-tuning. Microsoft Research has simultaneously released Farah 7B, an agentic small language model, purpose-built for computer use tasks. Built on the Qwen 2.5 VL foundation with a 128,000 token context window, Farah 7B represents Microsoft's first dedicated computer use agent in the small model category. The model perceives browser state through screenshots while maintaining textual records of reasoning and action history, then predicts next actions with coordinates for clicks and other interactions. Training took just 2.5 days on 64 H100 GPUs, using fully synthetic trajectories generated and verified by a multi-agent pipeline. The MIT license and on-device execution capabilities make this particularly interesting for privacy-conscious deployments where users want agentic capabilities without sending sensitive data to cloud providers. Self-hosted AI platforms and tools. For those tired of piecing together their own AI infrastructure, Bilgiken offers a cohesive self-hosted platform built on familiar components: Ollama for LLM inference, Spring AI for the application layer, PostgreSQL with pgvector for storage and retrieval. The platform bundles RAG capabilities, asynchronous task processing for long-running operations like document analysis, and a workspace structure for team collaboration. The differentiating factors here are the async AI tasks and reusable prompts. Features that acknowledge real-world workflows often involve more than single-shot queries. The project currently lacks Docker containerization, though that's on the roadmap. Community feedback highlighted the inevitable comparison to similar tools like Anything LLM and Onyx. But Bilgiken's strict local-first approach with zero third-party AI provider integration distinguishes it for users prioritizing data sovereignty. One commenter's advice to prefer llama.cpp over Ollama for maximum control reflects the ongoing tension in the local AI community between convenience and configurability. Meanwhile, the Open Web UI project just merged a substantial 2,600-line documentation overhaul, covering everything from multi-replica high-availability guides to RAM reduction strategies for running on Raspberry Pi hardware. The update includes a new tooling taxonomy section distinguishing native tools, workspace tools, MCP, Model Context Protocol, and Open API integrations, a tacit acknowledgement that the tooling landscape has grown complex enough to require its own classification system. Section: RAG and Data Processing Optimization. The semantic search layer of RAG pipelines continues to evolve with IMESD, In-Memory Streaming Data Engine, a zero-GPU vector engine designed for real-time data streams like logs, social feeds, or live monitoring systems. Built in Rust, IMESD uses SIMD-accelerated dot product kernels on int8 quantized embeddings to achieve sub-millisecond search latencies, 232 microseconds average on Apple M4 silicon, with throughput around 4,300 queries per second. The architectural choice of a sharded circular buffer means old data naturally flows out as new data arrives, creating what the developer calls an infinite window for RAG that keeps LLMs focused on recent context. The project includes a compelling demo, monitoring the global aviation fire hose from OpenSky API, ingesting approximately 10,000 aircraft states per minute, mapping them to semantic concepts like dangerous high speed at low altitude, and triggering local LLM analysis via Alama only when anomalies are detected. This event-driven approach to LLM invocation represents a more sophisticated pattern than blanket processing of every data point. On the data preparation side, a student developer released a Rust-based HTML to Markdown converter specifically optimized for RAG token efficiency. The tool strips navbars, scripts, and tracking pixels, the noise that consumes context window space without adding semantic value. Built on the readability crate for noise reduction and HTML2 text for LLM-optimized Markdown output, the converter is currently offered as an API service rather than open source, which drew some skepticism from the local FIRST community. The developer's explanation, wanting to gather usage data before maintaining a public repository, is reasonable, though the hesitation to send data to closed-source services in an era of AI slop reflects justified community paranoia. AI code analysis and software engineering. A thoughtful analysis on scaling LLMs to larger codebases introduces the concept of one-shotting versus rework, the distinction between an LLM generating working code on the first attempt versus requiring manual intervention that often takes longer than doing the work yourself. The author frames LLMs as choice generators, where every token represents decisions about variable naming, function organization, code reuse, and technology selection. The insight here is that prompts ideally capture only business requirements, while all other choices are either inferable from context or encoded in what the author calls a prompt library, documentation, best practices, and codebase maps that can be included as LLM context. The article references an anecdote from Meta where engineers reportedly admitted they weren't positioned to realize Zuckerberg's AI coding vision because their codebase is riddled with technical debt. This observation cuts to the heart of current limitations. LLMs reflect the quality of the environment they're given. Technical debt in the codebase means technical debt in the LLM's outputs. The solution proposed is investment in both environment, better context, and oversight, the skill set needed to guide, validate, and verify LLM implementations. Research from Meta proposes measuring AI capabilities by the time horizon of tasks agents can complete. Finding this metric has been doubling approximately every 7 months for 6 years. Tasks taking humans less than 4 minutes see near 100% model success rates, while tasks exceeding 4 hours drop below 10% success. The implication, if trends continue, AI agents completing day-long or week-long software tasks independently could arrive within a decade. For microservice architectures specifically, researchers have developed a bug localization approach that transforms codebases into hierarchical natural language summaries, enabling NL to NL search rather than cross-modal retrieval. Evaluated on an industrial system with 46 repositories and 1.1 million lines of code, the method achieved pass-at-10 of 0.82 and MRR of 0.50, outperforming both retrieval baselines and commercial tools like GitHub Copilot and Cursor. The key insight is that traditional RAG over raw code suffers from semantic gaps between natural language bug reports and technical code terms. Moving up the abstraction ladder to natural language summaries leverages LLM's semantic understanding capabilities more effectively. Practical wisdom from the trenches suggests treating PR risk as blast radius, not lines changed. Touching auth, database, config, or infrastructure code warrants splitting into smaller PRs with targeted tests regardless of how simple the diff appears. One developer reported success using Minimax M2.1 through Claude Code orchestrating 4 subagents for legacy C# modernization, with the model handling delegation, Linux tool use, and documentation updates, while human devs are debating whether that 2012 cron job is legacy or vintage. Hardware infrastructure for AI. A deep technical dive into PCIe switches reveals their value for multi-GPU LLM setups, particularly the Broadcom PX88000 Gen 4 and PX89000 Gen 5 series available on AliExpress for $100 to $500. The author explains these switches as Ethernet switches but for PCIe packets, They route transaction layer packets between upstream ports connecting to the CPU and downstream ports connecting to GPUs, with an internal crossbar switch fabric handling the traffic. The critical advantage for LLM workloads is peer-to-peer communication. Traffic between downstream ports, GPU to GPU, can traverse the switch fabric without going through the upstream port at all, enabling full local bandwidth for P2P transfers. This matters because modern LLM inference with tensor parallelism across multiple GPUs depends heavily on inter-GPU communication speed. Additional benefits include no bifurcation support requirements from the motherboard, flexible lane splitting, plug-and-play operation, and boot capability from attached drives. The switches work on both Linux and Windows, making them accessible to hobbyists building multi-GPU rigs without enterprise hardware budgets. For profiling GPU and CPU workloads, Zymetrace offers continuous profiling with automatic correlation of hardware profiles to the CPU code paths launching GPU work. The tool works with NVIDIA CUDA and PyTorch, using eBPF for low-overhead system-wide visibility. The Efficiency IQ feature promises actionable recommendations rather than just flame graphs that users must decode themselves, a recognition that profiling tools often generate more data than insights. Small language models and architecture. A developer's proof of concept demonstrates that small language models can achieve reliable accuracy with proper orchestration architecture. The pipeline starts with Phi 3.5 Mini, rewriting user queries into 4 alternatives, then uses Qwen3 embedding model for vector database retrieval across all variants. Results are deduplicated, re-ranked to approximately 10 hits, expanded to include neighboring document chunks, then passed to Qwen8b with thinking mode enabled for answering. Finally, Phi 3.5 Mini extracts and formats the response from the thinking model's output. The key insight is that small models enable rapid loading and unloading per request without prohibitive latency, and context engineering, not raw model size, determines answer quality. Running everything on VRAM with models small enough to swap quickly creates a responsive system that wouldn't be possible with 300B plus parameter behemoths. The developer built this in Godot Mono using LlamaSharp, llama.cpp under the hood, demonstrating that game engines can serve as viable platforms for AI experimentation. For those wanting to understand the mathematical foundations rather than just run models, Joseph Breeden's primer explains LLMs from first principles for readers with linguistics, statistics, or mathematics backgrounds. The document addresses why LLMs aren't stochastic parrots. With 50,000 tokens and 50,010 possible 10-word contexts, more than atoms in the observable universe, storing separate probability distributions is impossible. Instead, LLMs learn functions that generalize, exhibiting emergent phenomena where they learn concepts and relationships without explicit encoding. The important caveat: humans learn language from context within the world, not just sequences, suggesting future improvements may require learning language within this greater context. AI security and safety. Google's Bug Hunters team has documented a new attack class called task injection that poses distinct threats to autonomous AI agents. Unlike traditional prompt injection, where attackers include override instructions in data sources, task injection crafts environments presenting subtasks that appear related to the user's main task but result in rogue actions or data exfiltration when completed. The example given, a computer use agent asked to summarize an attacker-controlled web page might encounter a fake CAPTCHA whose solution executes malicious actions. Task injection bypasses prompt injection classifiers because it resembles normal web page text rather than instruction-like override commands. It also evades action alignment checks because the agent's actions appear aligned with the requested task. The researchers note that some legitimate use cases, reproduce this GitHub issue or solve this CTF challenge, require agents to follow untrusted tasks by design, making them particularly vulnerable. Several vulnerabilities in OpenAI's operator demonstrating these concepts were discovered, reported, and patched. As stochastic prompt injection mitigations improve and agents handle increasingly complex multi-step tasks, task injection will likely become a more prominent attack vector. On the defensive tooling front, a scanner for CVE 22E5-55182, addresses a CVSS 10.0 RCE vulnerability in React server components. The tool emphasizes surface detection rather than exploitation, identifying exposed RSC endpoints where exploitation chains might be attempted. The developer notes that most public POCs fail in production due to Next.js module whitelists, minified IDs in production builds, root redirects dropping post bodies, and transport format mismatches. The scanner addresses these common failure modes. Separately, FlagRep offers a Go-based utility using breadth-first search decoding to uncover obfuscated strings in files, useful for CTF competitions and malware analysis. Specialized computing systems. Kubes OS 4.30 arrives with significant infrastructure updates. DOM 0 upgraded to Fedora 41, Xen to version 4.1, default templates updated to Fedora 42, Debian 13, and Honix 18. The release also introduces a device self-identity-oriented assignment system and reintroduces Kube's Windows tools with improved features. For security researchers and privacy-focused users, the compartmentalized architecture, running applications in isolated VMs, remains the gold standard for desktop security. Kubes 4.2 continues support for 6 months following this release, until June 2026. In the realm of esoteric computing, a project celebrating TinyBasic's 50th anniversary creates a CPU that natively runs the language's virtual machine. Implemented in VHDL on a Digilent Anvil board, the design executes all 40 instructions from the original 1976 reference implementation, extended with for loops, input statements, and the modulo operator. Performance optimizations including a Goto cache allowed the CPU to outperform all tested retrocomputers except Digital Microsystems Hex 29 when calculating primes under 1000. The project demonstrates that hardware-software co-design continues to yield interesting results even for vintage languages. For image generation enthusiasts, ZImage Turbo AIO packages, Alibaba Tongyi Lab's 6B parameter photorealistic generator as an all-in-one comfy UI checkpoint with integrated VAE and text encoder. The model generates 1920x188 images in 8 steps, 34 seconds on an RTX 4060 with 8 GB VRAM, supporting bilingual English-Chinese text rendering. Available in FP8 and BF16 20GB variants under Apache 2.0 license. The package eliminates the usual friction of downloading separate model components. Just download and generate.